Hi guys, this is Vineet and I welcome you to this video. Today's video topic is temporal tables in SQL Server. We will discuss on these tables which are temporal tables. Before we proceed ahead, I would request all you guys to please go ahead and subscribe to my channel. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding my all future and upcoming videos. So let me give you 5 seconds. Please go ahead and subscribe right away. I'm waiting guys. Please go ahead and quickly subscribe to my channel. So guys, I hope you must have subscribed to my channel by now. So we can move ahead now. There are some points to remember while watching this video. Please watch this video till the end to gain better clarity of the concept. And if it's possible for you, please watch this video twice or as many times as you like or until the concept gets clear to you. Also perform any exercises in your test and lab environments only. Do not touch any production environment or production databases. We would like to know your thoughts regarding our videos, so please do share in your comments, feedbacks and suggestions. We eagerly wait for your comments and would love to read the same, so do post in your comments, feedback and suggestion. Let's move ahead. So guys, we have created some playlists for you to watch. So the reason we have created these playlists is because it enhances the learning of the viewer. Instead of viewer watching videos randomly here and there, it's basically a segregated way to work in any particular area. For example, if a user wants to learn about SQL Server database design, what we would recommend is that user should go to this SQL Server database design playlist. And this playlist has around 110 videos, and we expect user to watch all the videos from starting till the end to gain better clarity in that particular area. So ideal way to for learning is to go through a playlist and watch out all the videos in that particular area. Similarly, if you want to learn about SQL Server indexing, what we would recommend is go to the SQL Server indexing playlist or SQL Server indexes playlist and watch out all the videos to gain better understanding in that indexing area. So if we talk about this video pertains to the SQL Server database design category, where we will talk about the temporal tables. If we talk about the total number of videos posted on our channel, it's more than 260 videos at present. So the link for all these playlists and my channel page link is also given in the video description area of this video. So please check out the video description area. It contains lots of useful information, including the links to these playlists and my channel page link as well. Proceed ahead and come to today's topic, which is temporal tables in SQL Server. So let me show you what we will cover. So we will cover temporal tables overview. What are these? So we will cover temporal table. We will talk about the system version temporal tables. We will then talk on why to use the temporal tables. Then we will cover how the temporal tables work. Then we will move on to doing some demos. Show demos how to work with or to query the temporal data. And next thing we will cover is, maybe not in this video, maybe in the next video for this temporal tables. Maybe we will cover some partial stuff today, not complete stuff. We will try to cover as much as possible today itself. We'll see. So next we will talk about how you can create and manage the temporal tables. And after that, we need to discuss some demos. So there will be around 15 demos that I will need to cover. Then in our next video, we will cover the temporal table security. So let me start with the discussion on temporal tables. There will be some theory, and going through this theory is very much essential. So you should also go through it. So what are temporal tables? These are also known as system-versioned temporal tables. And this is basically a database features that bring in support for providing information about data stored in the table at any point in time. So the role of temporal tables is to provide the history information about any record in a table. So during the period of time during a span of time, a record goes through various changes. So the role of temporal table is to provide us this history information, what all changes were performed at what point of time. So that is basically the role of temporal table. So it basically provides the information about data stored in the table at any point in time, maybe in the history as well. And rather than only providing the data that is correct at the current moment in time. So instead of just providing the data which is current, it can also provide you the historical data as well. Now let's talk about the system version temporal tables, which are, the temporal tables and system version temporal table are one and the same thing. So a system version temporal table is a type of user table, and this is designed to keep full history of the data changes. All right. So basically, as I was talking that through temporal tables, we can keep the history of data changes to a particular row or a set of rows. We can keep the history information for all the rows. And it allows easy point-in-time analysis. So why we need historical information for any particular record? Maybe we want to do some point-in-time analysis of that data. And this type of temporal table is referred to as the system version temporal table because the system manages the period of validity for each row. So here in this case, here in the case of temporal tables, your system manages the period of validity for each particular row. That is the database engine. Basically, database engine performs that work. Here by system, we are referring to a database engine. So database engine automatically manages the historical information. So let's see how it works. Now, every temporal table has two explicitly defined columns. So if we talk about the temporal table, this table contains two additional columns. Now, each with the datetime2 data type. So the datetime, the data type of these two columns are datetime2. Now, these columns are referred to as the period columns. So we call these columns the period columns. So these are also known as period columns. These two extra columns are called period columns. Now these period columns are used exclusively by the system to record the period of validity for each row. So what is the role of these two columns? These two columns are used basically by the system to record the period of validity for each row whenever the row is modified. So some dates are maintained whenever a row is modified in these particular two columns. Now the main table that stores the current data. So here in the case of temporal table, we have a table that stores the current data and we have a table that stores the historical data. So the main table that stores the current data is referred to as the current table. So the table which contains the current data is known as current table or simply as the temporal table. So we also call this table a temporal table or the current table. And in addition to these period columns, so we were talking about the two columns that that a temporal table has. A temporal table also contains a reference to another table. So a temporal table also maintains reference to another table with a mirrored schema. So this another table also called the historical table also has a mirrored schema similar to that of a current table. And this table is called the history table. All right. And the system uses this history table to automatically store the historical data or previous version of each row. Each time a row in the temporal table gets updated or deleted. So whenever a row in the temporal table gets updated or deleted, let me mark it with another color. All right. So whenever a row in the temporal table gets updated or deleted, here we are by temporal table we mean the current table. So if a row in the current table or temporal table gets updated or deleted, the system keeps the previous version of the row in the history table. All right. And during temporal table creation, we can specify an existing history table as well. So during the temporal table creation, we can also specify the history table. And this history table must be schema compliant. So this history table must be schema compliant or let the system create the default history table. So if we do not specify the history table definition during the temporal table creation, the system automatically creates the default history table with a similar schema as of current or temporal table. Now, why to use the temporal tables? Now, real data sources are dynamic And if we talk about business decisions, they rely on insights that analysts can get from a data evolution. So sometimes if we want to see the trend, the analysts need the data from the history as well, so that they can check the data evolution, how data got updated, what is the trend of data update. So for this information, the analysts need the information on the data evolution. And let's discuss some of the cases or use cases for the temporal tables where the keeping the temporal tables are useful. So there are some situations where we do need to keep the temporal tables. Whenever we are doing the auditing, if we want to do auditing, all data changes and performing data forensics when necessary. So we need to keep the historical data. We are doing some kind of auditing. So in those cases, temporal tables are useful. Second use case can be if we are reconstructing a state of data as of any time in the past. Third use case can be if we want to calculate the trends over time, and if we want to maintain a slowly changing dimension for decision support applications. Another use case scenario can be recovering from accidental data changes and application errors. So we can recover from those accidental changes using the historical tables. Okay guys, so we have discussed about some of the use cases of the temporal tables. Now let me show you how the temporal tables work. So system versioning for a table is implemented as a pair of tables. So as we already talked, we have a current table and we have a historical table. Now current table and a history table, yeah, this is what we are talking about. So we keep the current table and a history table. Now within each of these tables, two extra datetime, two columns are introduced or used to define the period of validity for each rows. So in both of these table, we have two extra columns, and these are of date, data type date time 2, and these two columns are called the period start column and the period end column. So period start column specifies the system records the start time of the row in this particular column. So in this column, the system records the start time of this row, and typically this is denoted as valid from column. So the actual name of the column is valid from column, and we have a period end column, and this is referred to by the valid to column in the table, and the system records the end time for the row in this particular column. So the start time contains the start time of the row, the end time contains the end time of the row. All right, and the current table, if we talk about, it contains the current value for each row. The history table contains each previous value, the old version of each row, if any, and the start time and end time for the period for which that particular row was valid. So here we have a snapshot of a temporal table along with the history table. So whatever the older row version gets updated to the history table and removed from the temporal table. So history table keeps track of the older data or historical data, and we see that user performs update, delete, insert, and bulk inserts to the temporal table. So whenever these operations are performed on the current table, the older version of the rows, the older data gets updated to the history table, and current data gets written to the current table. Now let me take you through a demo. Let's do a code discussion that illustrates the scenario with the employee information. Then we will talk about how to query the temporal data. So let's do some code discussion. So let me invoke SQL Server. We will create a table, and this table will be the employee table. And we are creating this table as temporal table. So pay attention here, guys. In the meantime, if you have not subscribed, please subscribe right now. That is very much essential, guys. So guys, SQL Server is invoked, and let's connect to the default database engine or default instance of the SQL Server. Let's use the My AdventureWorks. In your case, it will be AdventureWorks 2022 database that we are working with. Now, let me create a table structure so you may write code along with me. So I'm creating a table name employee, and let's define the structure for that particular table. So first, the first column I'm taking is the employee ID column. So let's take employee ID as the first column, and this will be of integer type. It will not accept null, and this will be a primary key column, and the index created will be clustered by the primary key. And second column I'm taking is the name of the employee. And let's take it as an varchar column. N is particularly used for the Unicode characters. Otherwise, you can take varchar column as well if we are not storing any Unicode characters. It's better to take n varchar these days. So this column will be not null. Let's check the position. Let's take position. Let's take it as varchar and not null. So this is another column. Let's take a department as well. So position of the employee, department of the employee. Let's take it as varchar 100, and this will also be not null. Another column we can take is the address of the employee. So let's take address. Let's take it as an varchar of 1024 characters. Let's specify that this column will not accept nulls. Now we are specifying two columns we are talking about for storing the history information. So these are valid from column. So we are taking them explicitly. This should be of date time type 2. All right. And as these are special columns, we need to specify some additional keywords along with it. So this is of date time type 2. Let's mark this column as generated always as row start. So you need to type in these keywords or for these particular columns, the valid from and valid to. So the valid from column, for the valid from column, you should write generated always as row start. And let's take another column, valid to. And this should also be of time data type, date time to type. And along with this column, we mentioned that generated always as row end. So that a system should keep track of row start and row end in this column, the historical information. And next we have to specify period for system time valid from valid to. So guys, note down the structure, specifically pay attention to these last three rows that we have taken in the structure of the table employee. We have taken a valid from column, and the additional statement with this is generated always as row start, and we taken a valid to column of date time to type, and with that we have specified the statement generated always as row end. And the third row, in the third row we have specified period for system time, and so the system time is valid from and valid to. So this is the syntax you should be taking while creating the temporal tables. So you may take a screenshot if you have not already typed for the structure of the temporal table. And in the end, we specified that we need to turn on the system versioning for this table. So that is required to keep the historical information. So we are setting system versioning to on, and we are specifying the history table as well here. If you don't specify the history table, the system will automatically create its own history table. So for history table, I'm specifying the employee history as the table name. So yeah, that's it. That's the structure of the temporal table employee that we are creating. So let's go ahead and execute this statement. So a table is created. If we look at the table section, we should have this table. So employee is the temporal table, and along with that you see that it's system version table. So if you take a look within the brackets, it is showing as system version. So any of the tables mentioning as system version, these are temporal tables, and you see a clock icon along with that as well. And for column, you see under that table we have a subtable which is an employee history table, you see here. So each of these tables have valid to and valid from column. So this is the start date, this is the end date, and similarly we take a look at the history table columns. It has a similar schema as that of the current table, which is the employee table. All right, so this is how you specified a system version or a temporal table. Now let me talk about the inserts to this table. What if we insert a data into this table? So whenever we insert a certain row within this table, the system sets the value for the valid from column to the begin time of the current transaction. All right, so we can do a insert as well. So let's put some data. You need to specify the columns as well. So employee ID is primary key. I think but you need to specify it's not an identity column. You need to specify something. So let's take employee ID. Employee ID. Next thing we need to take is the name. Next column we need to fulfill is position. Let's take department. Let's take address. We have missed one column, but yeah, let's leave it. There was a salary column as well that we need to put in. But yeah, let's keep it till address. Yeah, these are the only columns for which we need to supply the information. So we are doing some inserts, right? So let's insert one row into this table. So let's take one for employee ID. For name, let's take David is the name. David Miller is the name. Let's take position as senior software architect maybe. And let's specify the department R&D as the department. And let's define his address. Maybe take ABC SFO is the address. This is just a sample address. So let's insert this row into a table. So here we are talking about the inserts. So the actual syntax would be insert into the employee table, which is a temporal table. And then we need to specify the columns. Then you need to provide the information. So it's not values, it's values actually. So let's insert this data into the table. So whenever the insertion is performed into the temporal table, let's try to see the data from this table. Let's do select star from employee. Let's see what all rows do we get. So we are getting all the rows including the valid from and valid to column. So you see the data for valid from is automatically provided, which is the current date time when the insertion was made. And for the valid to date, it has automatically taken the maximum value of 31st December 9,999. It has taken a maximum value for this particular column. All right, for each and every row. For the valid from column, it takes the current time when the transaction was executed. So for any inserts, the system sets the value for the valid from column to the begin time of the current transaction in the UTC time zone. So these time zones, if we talk about, these values are in UTC time. All right. And it's based on the system clocks, and it assigns the value for the valid to column to the maximum of 31st December 9,999. And this marks the row as open row. So this is an open row if we talk about. Now let's talk about the updates. So right now if we take a look at the history table, so there's a history table as well. So there won't be anything present in the history table of employee. Employee history is the table name for that history table. So let's select something from employee history. But this doesn't contain any row, whereas employee contains the row. Because right now we don't have any historical information created. So whenever we perform update, delete, insert, and bulk insert. So guys, whenever an update is made or delete is made to the current table, then the historical information is maintained. All right. So if I go back to SQL Server, if we talk in regards to updates, the system stores the previous value of the row in the history table. If we make an update to this particular row, the system will store this row in the employee history table. All right. So system stores the previous value of the row, which is this one, in the history table, and sets the value for the valid to column to the begin time of the current transaction. So this will be updated to the time of the current transaction in the UTC zone based on the system clock, and this whole row gets stored in the employee history table, and the employee table contains the current data regarding whatever update we are storing in the employee table. So let's try to do an update quickly. So let's perform an update to the employee table, and we are basically setting the position. We are changing the position from senior software architect to software architect. So let's do that. Set position equal to software architect from the senior software architect that was earlier. Maybe let's change it to enterprise architect instead from the senior software architect, we are changing it to enterprise architect, and we can specify the criteria where employee ID equals 1. Make this change. All right. So at this time, I'm updating the change. So a historical record will get updated and get stored in the employee history table, and the current version of the record will show up in the employee table. So let's execute it. I've executed it. Now, if I check the employee history table, that will contain the historical information. So this contains the senior software architect now. I'm talking about the history table. This contains the historical information, and the valid from was taken from earlier. And valid to column is set to the begin time of the current transaction whenever the transaction was executed based on the system clock, and this time is R in UTC, guys. And this basically marks the row as closed with a period recorded for which the row was valid. And if we take a look at current table, which contains the open row, so in the current table, if we take a look, in the current table, if we see the updated row, right? The row is updated with its new value, which is enterprise architect, and the system sets the value for the valid from column to the begin time of the transaction, which is 4:56 in the UTC time zone based on the system clock, and the value for the updated row in the current table for the valid to column is set to the maximum value of 31st December 9999. So this is how it works. I have made an update. The historical version of the row is stored in the employee history table, and the employee table is currently stored in the current version of the record. All right, so we have talked about updates. Now let's talk about deletes. So whenever we perform a delete, the system stores the previous value of the row in the history table and sets the value for the valid to column to the begin time of the current transaction in the UTC time zone based on the system clock. So whenever we delete the row, it deletes from the original table altogether, and the previous version of the row gets stored in the history table. Basically, if we delete this row, this is from the current table, the record will get removed from the employee table, which is the current table or the temporal table, and the history table will contain the information of this record. Whenever we delete this record, the system stores the previous value of the row in the history table and sets the sets that value for the valid to section. All right, to the begin time of the current transaction based on the system clock. This marks the row as closed with the period recorded for. Okay, let's do deletion first and then see. So if I delete the row, delete from employee where employee ID equal to 1. So after doing this, we don't have any row, we will not have any row for employee ID 1 in the employee table. So we have deleted the row. If we select from employee, we don't find anything. Whereas if we take a look at the employee history table, it will now have 2 rows. All right, so let's see. So these are the 2 records. This is the earlier record, which was valid from 2/8/2024 time 4:42 UTC till 4:56 UTC. This was valid. And when we deleted the data, which was this row, now the record was valid from this time, which has taken as the valid from time, to the current time of the transaction. So this marks the row as closed. So both of these rows are closed. And currently, the employee table does not contain any information for employee ID 1. All right. So the fourth operation is the merge operation. Now, in the current table, the row was removed. We have already checked the row was removed in the current table. Queries of the current table don't return these rows. Only the queries that deal with the history data return data for the row that is closed. So in the employee history table contains the data for this employee ID at this moment, and these are the closed rows. Any rows that are present in the employee table are open rows. And basically, if we talk about the times recorded in the date time 2 columns, which are these 2 columns, are based on the begin time of the transaction itself. For example, all the rows inserted in the within a single transaction have a same UTC time recorded in the column corresponding to the start of the system time period. So alright, I think this much information is enough. Now let's talk about how we can query the temporal data. So how to query the temporal data. Now this, if we talk about the select from table statement, has a new clause for system time. So we can include this clause. If you take a look at this diagram, so if you want to select records from the history table, either you can directly query the history table. Otherwise, you need to specify this clause if you just want to query the current table, because the users are not aware about the history table. They will only query the current table. All right. So they can include the clause for system time. All right. So the select from statement has a new clause for system time, which is this clause with 5 temporal specific subclauses. So below that we have subclauses which are all, as of, between, and, from, to, contained in. These are the subclauses. So temporal specific subclauses to query data across the current and the history table. And this new select statement syntax is supported directly on a single table, propagated through multiple joins and through views on top of multiple temporal tables. Now, when you query using the for system time here, mentioned here, the clause for system time, using one of the 5 subclauses given here, historical data from the temporal table are included. So whenever we use these clauses for system time and all the other subclauses, the data gets returned from the historical data gets returned from the temporal tables. All right. And we don't have to specifically query the history table. All right. So let me share you an example of a query on how you can query a temporal data. So instead of directly querying the history table, we can still get the temporal data while only querying the current table. So let me show you how to do that. So let's write a query quickly here. Now, if we run a for doing query, so let me first select data from the employee history table. So this I have executed against the employee history table. So now if you want to get the same data while querying the employee table, so right now if you query the employee table, you get nothing. So there are special subclauses that need to be used if you just want to query the employee table and get all the historical information like this. So let me show you how to write that query syntax. So we need to write select star from, and we need to specify the table name, which is employee. And this time we need to include the for system time clause because we are looking for historical data. So we need to provide this clause. So this is the main clause, and under that you need to provide the subclause. So what are those subclauses? So we have these subclauses, all, as of, between, and, from, to, contained in. So out of this we will be using the between time clause. So we want to search a data between certain time range. So let me take a time range, this and this. So if we just type this time range, let's take this, right, omit this part, and let's just take another time range. Maybe let me copy this and provide the date time range manually. So let's say if we want any records between the 57, let's say. Let's see how many rows are returns. For this, the end date is 5 a.m. UTC time on 2/8. I've taken a time little lesser than that. So let's see if both the 2 rows are returned or only the first row gets returned where the senior software architect is written. So let me execute this. And here, guys, if you observe, I'm just querying the employee table and not querying the employee history table. But still I will get historical information if I use the for system time clause and the subclauses between. So let's query this table. So we got both the rows. So it does not check on the valid to column, but it checks on the valid from column. So this is how you can fetch the historical data by querying the current table. And we can also specify subclauses as well after this. So after this, you can specify the clauses. If you want to say, just check for employee ID equal to 1, you can specifically mention that. Your for system time and between clauses should come before the where clause. All right, so this is the exact query you need to execute, and you can order it by valid from as well. So you can do order by valid from, that can be done to get the data in a sorted manner, all the rows in a sorted manner. This for system time clause that we have taken, it basically filter out rows that have a period of validity with 0 duration. So if any rows that have 0 duration, that is between the valid from and valid to clause, which are in which both the dates are same for valid from and valid to, and the for system time will filter out those particular rows if the valid from and valid to dates are same. And basically these type of rows are generated where we have same values for the valid from and valid to columns. These type of rows are generated if you perform multiple updates on the same primary key within the same transaction. But here we have not made such updates where we are modifying the same row multiple times in the same transaction. Now, in that case, temporal query returns only the rows versions before the transactions and current rows after the transactions. And basically, if you want to get all the data, you can directly query the history table so that you do not see any filtrations. Because sometimes the system time clause filters out any special kind of rows. So if you don't want any filtration, you can directly query the employee history table to get out the information. All right. So I think I've shown you one clause that should be enough. Uh, Let me see what other items we need to discuss. And okay, guys, let's talk about creating and managing the temporal tables. Now, depending upon the scenario, you can either create a new system version temporal tables or modify the existing ones by adding temporal attributes, which are basically two columns, valid from and valid to. So we can also add temporal attributes to the existing table schema as well to make them temporal tables. All right. Otherwise, we can create new system version temporal tables altogether. Now, when the data in the temporal table is modified, the system builds version history transparent to the application and the end users. So the if the temporal tables are being used and when the data in the temporal tables are modified, the system in the background automatically builds the history information, builds the version history information. And this creation of version history information is altogether transparent to the application and the end user. So basically the applications and end user don't see this history stuff whenever they are working with the temporal tables. Now, as a result, working with the temporal table doesn't require any change to the way table is modified. So basically it doesn't require any change at the part of end user or the application. Application will keep on working with the current table as well as the users can also keep on working with the current table. So this doesn't require any changes to the way table is modified and how the latest state of data is queried. So if we just want to query the current state of data, that doesn't change require any changes to the way table is modified or something. Now, in addition to regular data modification and querying, temporal table also provide convenient and easy ways to get insights from data history through extended SQL syntax. So we can use the extended transact SQL syntax to get the history information. So we can even get history information by using a special syntax even while querying the current table instead of querying the history table. Now, every system version table has a history table assigned, which is transparent to the users. Now, this history table is also transparent to the users and not visible to the users. What users do is they only query the current table, and they can also get the history information by using the specific clauses to get the history information. And below is the workflow for the temporal tables we have. So for data definition language, we are using create table and temporal table for system time, etc. We had shown you the syntax how to create the temporal table. So we specify this period for system time, right? While creating the temporal table. So we create table temporal and then we specify period for system time. And if we want to alter the existing table, we do alter table and then add the period for system time clauses along with those two columns, the valid from and valid to. And data manipulation languages will perform the insert, bulk operation, update, delete, and merge operations. Querying, we can do select star from temporal table. And for temporal querying, or history data querying, we can use specific clauses and subclauses. We use the for system time clause and various subclauses for under the system time. These subclauses are as, of, from, to, between, and quantitative. We have shown you how to use the between clause here in the query. So here we have shown you how to use the for system time clause and the between subclause to get the history information. Even though we are querying the current table, we still get the history information. The joins will automatically be created in the background to provide us such information. Now there are certain demos to be covered. So first we will cover the create demo, where we will create a temporal table with an anonymous history table. So there are three ways to create the system version temporal tables when considering how the history table is specified. So there are three ways to create these temporal tables, so which are covered under demo 1, demo 2 and demo 3. So we can create a temporal table with an anonymous history table, which is this one. And we can also create a temporal table with a default history table. And then we can also create a temporal table with the user defined history table. For creating a temporal table with the anonymous history table, so that is the first scenario we are covering. So we can create a temporal table with an anonymous history table where we specify the schema of the current table and let the system create the corresponding history table with auto-generated name. So this is the one of the situations where we don't specify the history table name. In our earlier example, we had specifically specified the history table name here. But yeah, in certain cases where we want to keep the anonymity, we can create a temporal table with an anonymous history table. So in this case, the system will automatically create the corresponding history table with the auto-generated name. All right, let's cover this topic. So creating a temporal table with the anonymous history table is a convenient option for quick object creation, especially in prototypes and the test environments. And this is also a simplest way to create a temporal table since it does not require any parameter in the system versioning clause. So in our earlier query, we have specified the parameter in the system versioning clause. We have specified the history table parameter to specify this particular history table to be created and used. For anonymous history table, we don't need this parameter altogether. This is the simplest way to create a temporal table since it does not require any parameter in the system versioning clause. Now let me discuss an example where we will create a new table with system versioning enabled without defining the name of the history table. So let me show you how you can create this table. So let's go to SQL Server. Let's create a new query altogether. So you can type that syntax along with me. So here we are creating an anonymous history table. So we don't specify the name of the history table. So we are creating a table called department. Let's give this table name department. And let's specify some of the columns for the department table. Let's take department ID. It will be an integer not null column and it will be a primary key, a clustered primary key, I would say. Second column I'm specifying is the department name. So let's take this column and this will be of varchar type. Let's take 50 as the length, and this will be a not null column. And let's take manager ID, the manager for that particular department. And I'm just giving the ID, and this can be null. And let's take parent department ID, another column integer type can contain null values. And let's create the valid from and valid to columns. So valid from date, the data type will be date time 2. So let's specify date time 2 as the data type. And there's a special statement we write. Can you remember what is that statement? So we type generated always as row start, not null. Not null is the clause that it does not contain nulls. And similarly for valid 2, we specify date time 2 and we specify generated always as row end, and this will also be not null. All right. So this is how you specify the statement, and in the end you specify period for system time. This is the statement you specify, and you specify valid from to valid to. So this is how you specify, and later on you specify with system versioning set to on. So specify system versioning should be set to on, and you should take these item within the brackets for it to be correct. So this is how you specify the table definition. Here we have not specified the history table name. Alright, so system will automatically create a table with the anonymous name. So a new table is created with system versioning enabled without defining the name of the history table. Now let's discuss, let me create this table. So this department table is now created. So this is also a system version table, which have come because of this. And this is a temporal table. And if we take a look here, there's a history table created for that. And this is an anonymous table. The name was provided automatically by the system. We have not explicitly specified the name of the history table here. So let me discuss some of the remarks related to this creating table with the anonymous history table, creating a temporal table with the anonymous history table. So a system version temporal table must have a primary key defined. So this is a requirement. So system version temporal table must have a primary key defined and have exactly one and should have exactly one period for system time defined. So it should have a primary key defined. It should have exactly one period for system time defined with two date time columns, which are these declared as generated always as row start and row end. So it should be specified like this. And the second remark is that the period columns are always assumed to be non-nullable. So these columns, these two columns are always assumed to be non-nullable, even if nullability isn't specified. So here we have explicitly specified that these columns will be not null, even though if we do not specify this here explicitly, it is assumed to be not null. Alright, so these columns cannot take null values, even if the nullability isn't specified. If the period columns are explicitly defined as nullable, so here if we explicitly define them as nullable, so if we do like this, these columns cannot be null. So if we try to execute this statement will fail immediately. So these we cannot specify these columns as null. We cannot otherwise be able to create the table. Let's discuss the next remark. Now the history table must always be schema aligned with the current or temporal table. So here if we take a look at the history table, this is automatically aligned with the columns. Whatever columns are there in the current table, the history table columns must be the same. So here if you take a look, all the columns are same. So the history table must always be aligned with the current or temporal table with respect to the number of columns, column names, ordering and data types. So data types, names and ordering should be same for the columns in the history table. Next remark is that anonymous history table is automatically created. So here we have an anonymous history table specified by history here. So this table is automatically created in the same schema as current or temporal table. So we see that we have same schema as that of the temporal table. Now the anonymous history table name has the following format. So this is the format for the name dbu dot msql underscore temporal history for underscore, then some temporal table object ID, then some suffix, etc. Now this suffix is optional and is added only if the first part of the table name is not unique. Alright, let's ignore that. Now this history table is created as a row store table. So this is a row store table, not a column store table. And page compression can be applied if possible. Otherwise the history table is uncompressed. So by default this is an uncompressed table. But yeah, we can, if we want, we can apply a page compression to it. And basically for some configuration earlier, we discussed about the sparse column. The sparse column doesn't allow for compression. All right, that's not really very important here. Now, a default clustered index is created for the history table. So a default cluster index is created for the history table with the auto-generated name and format. So let's see if we have an index is created. So we see an index is automatically created, which is this is a cluster index. This cluster index is also automatically created for the history table with an auto-generated name in format ix underscore history table name. So whatever the name of the history table, it's generated as ix underscore whatever the history table name is, same as history table name. The cluster index contains a period, columns, and start. So this is an index created on the columns period and start. So these columns, the index is created on. All right. If we talk about this index, it is created on these two columns. So guys, we are done with this practical. We have shown you the demo one where we have created a temporal table with the anonymous history table. All right, guys, let's discuss on demo 2 where we will create a temporal table with the default history table. Now, if we talk about creating a temporal table with the default history table, this is a convenient option when you want to control the naming. So in case you want to control the naming of the history table, then this is a good option if you can create a temporal table with the default history table and still rely on the system to create the history table with the default configuration. So let me repeat that again. Creating a temporal table with the default history table is a convenient option when you want to control the naming and still rely on the system to create the history table with the default configuration. So here we just specify the name of the history table, but in the background the system creates the same table, whatever name we have specified with the default configuration. Now let's discuss one of the example where we will create a new table with system versioning enabled with the name of the history table explicitly defined. Now let me first remove this temporal table maybe. So let's go ahead and remove that quickly. Right click on the temporal table. Department table is what we have created, which is a temporal table. Let me go ahead and delete that table quickly. So are we getting the delete option? Okay, I'm not seeing any delete option, but yeah, we can give a drop table department to drop the table. Let's execute this statement to drop this table. So the drop table operation is failed because it is not a supported operation on system version temporal tables. So here we have created the table and basically we need to turn off the system versioning if we want to drop these table. So let's go ahead and drop this table by disabling the system versioning. Give me a few minutes, let me do that. So guys, I'm back. So basically you cannot drop a temporal table or a system version temporal table. Both the current and history tables are protected for temporal tables until the system versioning attribute, which was set to on, should be turned back off. Now, when you set this attribute to off, both tables automatically become non-temporal tables and are fully independent of each other. Therefore, you can perform all operations against them that are allowed according to your permissions. And you can also drop the period if you definitely want to convert a temporal table into a non-temporal one. So let me execute some code to turn off the system versioning. So we need to alter the table first to turn off the system versioning before we can drop it. So let's give the name of the table dbo.department. And to set the system versioning off, we can specify this clause system versioning equal to off. So this is the statement which you can execute to turn off the system versioning on this table. After that, you should be able to drop this table. So let's execute this. This is executed. Now system versioning is off and we can drop this table easily. Let's drop it. Our table is dropped. If we refresh the table section, we will not be able to see that table. The department table is dropped. All right. So now we were talking about creating a temporal table with the default history table. So for that, what we need to do is, so rest of the syntax is same, but if we want to create a temporal with the default history table, yeah, we can give a name to it. However, we can also specify within the brackets, we can specify the history table name like this, and we give the history table name. So let's take the history table name as dbo.department history as the table name. So this is the syntax which you can give. So it's not history name, but instead you need to type the history table. History table. So this is the correct syntax. So let's execute these statements to create a temporal table with the default history table. But here we have specified the name of the history table. However, the system in the background will automatically create this table with the same name, department history, and it will copy out the configuration of the actual temporal table, the schema configuration. Alright, so I've executed this. Now if I refresh the table, I will see the table department, which is system version table, indicating that it's a temporal table. And if we expand the table, we see a department history table is created, and this is a history table indicated here. And we can check the schema. Schema should be same as that of a temporal table. So here we have a same schema, same number of columns, same data type for each and every column in both the tables. Now let's discuss some remarks in relation to the creating a temporary table with a default history table. Now the history table is created using the same rules as apply to creating an anonymous history table. There are some rules that apply specifically to the named history table. So in this case, we have used the name history table, which is dbo.department history. So there are certain specific rule applies when we create a temporal table with a default history table. Now the schema name is mandatory for the history table parameter. If the specified schema doesn't exist, the create table statement fails. So if we are specifying the history table name here, it is very much essential and mandatory to specify the schema name. So in this case, we have schema name DBO, which we have specified. If we don't specify this schema name, our operation will fail. Now, if the table is specified by the history table parameter already exists, so if in case this table already exists, it validates against the newly created temporal table in terms of schema consistency and temporal data consistency. And if you specify an invalid history table, the create table statement fails. All right, so we are done with demo 2, guys. Let's discuss on demo 3. All right, let's divide this video into parts, otherwise this video will become very big. So let's keep it up till 2 demos covered in this video. We need to create a part 2 of this video where we'll cover the rest of the demos from 3 till 15. So keep an eye for next part of this video where I will cover rest of the demos. For now, I'm taking it as part 1 of the temporal tables video. So guys, I hope you like this video. Today we have covered the discussion on temporal tables or system version temporal tables. We have discussed about why to use the temporal tables. We have discussed some use cases where you can use the temporal tables, and we have shown you how the temporal table works, talked about the columns, the period columns stored inside the temporal tables, and we have shown you how you can query data from the temporal tables and how to get the history information out of the temporal tables. Next, we talk about how you can create and manage the temporal tables. We have discussed the workflow of temporal tables. Then we have covered 2 demos today. Rest of the demos we will cover in part 2 of this video, guys. So you should be subscribed if you want to get the notification regarding the part 2 of this video. If you have not subscribed yet, please go ahead and subscribe right away. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my upcoming videos and future videos. And also, if you want to get notifications for the next part of this video, please do subscribe right away, guys. So I'm giving you 5 seconds. Please go ahead and subscribe right away. So guys, I hope you must have subscribed by now. If you have subscribed by now, please go ahead and click on the like button on this video, and do post in your comments, guys, whatever questions you have, and if you have any concerns, feedback, reviews, suggestions, do post in your comments, guys. We eagerly wait for your comments and would love to read the same. So do post in your comments. And also, guys, if you have good network of friends, please get in touch with them. Ask them to subscribe to my channel if you feel my videos can make difference in their life. You can share my videos with them by the share button that comes below each and every video. You can use that share button to share my videos with your friends over any of the social media platforms. So I thank you so much again for your time on this video today, and you have a wonderful day ahead, guys. Thank you.